We have a MacBook Air. The description says dead. Hmm. uh, I think I know why this came like this. See the name, it's no longer there. The boss probably saw in the video that the name appears, so anyway, shouldn't. So I decided to remove the name. You understand what I'm saying? Like, usually the sticker is full with Marco on it.
Yeah, yeah.
So I think they saw in the video, so they decided, hey, we had to tell her to make sure this is cut out before. I think so, yeah.
Yeah.
You don't get what I'm saying, do you?
Yes, there should be a name here like this.
Yeah. So maybe he told her to make sure that it's cut out. In any case, okay, it is a. Was this machine booked in?
It's book, it's book team. If you want to ask also, I was looking for say this machine.
This is the serial number.
Yes,
Okay, but yeah, but how come there is nothing? If it was booked in, where is the sticker that we put on it?
this has been booked in this one. That is the last device I was making a video with you.
The last device.
Yes.
Okay, 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 okay. Okay, so the device is dead. We are not going to connect our charger because we are not sure what the state is. Let's quickly take out the screws, then we can connect our charger. It's an A15. It's an A1466 MacBook Air, 13 inches. You see how the screwdriver slips. That's why you try. I always try to make sure I guide my screwdriver because you don't want it to slip and thereby create scratches on the machine. Okay, back cover is out. This is the 2013, 2015-17 MacBook Air. How do we know that? We can tell that from the JTAG. We talked about how you can easily use the JTAG to differentiate between a 2013, 14, 2015, 2017. So because of the JTAG, we can confirm that this is indeed the 2015, 2017 MacBook Air. Now that the back cover is out, we can confirm we don't see signs of liquid. So the next thing we want to do is we want to connect our charger to see what we have. I'll call him back. Let's connect our MagSafe 2. We don't have charger communication. Okay, so let us disconnect the battery. Try again. Now we have charger communication, but no fan spin. Okay, let's see what we have. Do we have, okay? Uh, okay, let's see what we have. PP3V42 present. We can check PP3V42 on this inductor. Let's quickly open up the board view. You guys have an idea of what you did anyway. Hmm? Nabil, what they said that he wants to say, I'll get back to him. Okay. Let's open up the board view. A14. So that is a board view. And, So we want to check for PP3B42 present at the inductor here, L7095. Let's see if we have a PP3B42 present, black probe on ground, and then red probe and inductor. It should be present because we have an LED on our charger. If we didn't have PP3B42, that wouldn't be present. So, but let's just confirm that's 3.4 present. Let's check our PP bus. What do we have? PP bus is 8.59. That means our SMC is running at that level. Let's see if we have an SO rail here. We can check for an SO rail at this inductor here. We can here L5220. Let's see if we have an SO rail present there. Okay, 0.10. Okay, so the SO rail is partially present. So it's not a. So it looks like the SO rail is trying to. The machine is trying to go into SO because we having 0.1 zero point 0.1 in our SO rail. Okay, so let's take the board out. So this would mean that we have a particular rail on the board that is partially that is partially active. So let's see what rail that is. The battery screws on this machine has already been taken out. Let's now quickly take out the board, confirm what rail is trying to be partially active on the other side. When it fell, it looks like the magnet fell off, yeah? So when you are working on these devices, there are certain parts you really don't have to take out. For example, the SSD. If you don't have a need to take the SSD out, if you're not walking around that section of the SSD, there's no need to take the SSD out. The fan also, you don't have to take out the fan because you need the fan to be on the board to confirm for when you do need to look out for a fan spin. Now, when you're disconnecting the antenna cables, be very careful not to break the tips of the antenna cable. Okay, put that aside. Let's check on the other side what rail it's trying to, it's pulling our SO down or causing our SO not to be created. Let's give it a thorough inspection. Um, so this is a 1.6. 1.6 tells us that it's a 2015. 1.6 i5 4G. This is a 2015 board and now the 2017. So let's see. Okay. Okay. So this may be why. If you look at this section of, you see this section. See there is a bit of liquid in that section. This may be why our SOL is not fully created. And then you also have this. This is really not going to be a problem. That is fine. That part is still fine. But this is definitely a concern. So let's take out let's take out E7501 and then check again. E7501. So that needs to be replaced. Okay, that is out. Let's clean it. Hmm? Good, good, good. There you go. Otherwise, you're right. Good, good. There's a particular pad here that was affected. That pad is on E7501. That pad is PP bus. Okay, okay, I see you. So PP bus. So that pad is affected, and obviously E7501 require PP bus voltage to create its output rails. So that pad was somewhat affected here. That's here. If you can see, yeah, that one. So we need to recreate it. Yeah. So so clean that once again. Okay. Let's have solder at that point. Uh, the tip of this iron is really not. Yeah, sometimes, yeah, but other times, if with that one, but you know, if you capture all the details. So if you get busy, then we don't have to. Until we buy another one overhead. Also one. 15. Yeah, 15. Okay, let's grab another board for E7501. It's already taken up here. So by the way, the E7501 is quite a common component. It doesn't have to be from MacBook. You can also get it from a MacBook Pro Logic board. Thank you. Yeah, I'll do. Thank you. Which one? No, man. That is. I'm not gonna give you that back. I mean, I'm giving you a free Logic. Oh, that one. Okay. No, should I give you that back? No, I don't have to give you that. Didn't you take back the other one? Yeah, yeah, no, but didn't you take back the first one? Yeah, so yeah, so let me keep that one. Thank you. Ha! Thank you. Okay. Why not bring your car inside? Inside, we get parking.
Don't tell me now.
Yeah. Like, it's better inside the park your car outside. So when you solder your chip, you want to make sure there is no breaks along the component lines. So as you can see, this the components, the lines are distinct. 22, for example, is not the same as 21. 20 is not the same as pin 21. Pin 19 is not the same as pin 20. So when you replace the component, make sure there is no bridge between either of the pins. So that's what we making sure. So that is in place. And let's check out this section of the SMC just to be sure that nothing. Okay, yeah, pretty much that's fine. So here, the mm, okay, seem to be fine. Before we clean the board, let's just see if we now have. Guys, remember, I don't like to have my fan connected. I don't have a heart attack expecting the fan spin. First, I want to see what I have on my multimeter. Then I can decide if it's okay to connect my fan. Okay, so what do we have? And also, guys, because we don't have an IO board cable connected, do not expect to have an indicator on the charger. There'll be nothing on the charger because there is no IO board cable. What I'm talking about is this. Because this is not connected, so this is required for MacBook Air for the IO board. The IO board cable is required for the LED on the charger to come on. So if this is not connected, do not expect the light to come on, among many other uh, but for this particular application, if the cable is not connected, you don't expect to have charger indication. So the next thing we want to do is we want to see if we have a PP342 just to confirm it. Okay, great. Now the reason why we confirm with PP342 is because we want to see that we want to ensure that our charger is communicating with our machine. The next thing we want to do is we want to see if we have what we have in our PP bus. It was 8.5, which is fine. Now let's see, do we have our SO rail? Remember, we started to measure on our SO rail, which is L7520. and it was barely present. So it tells us that it's trying to create it, but something was pulling it down, which is what led us to U7501. U7501 has now been replaced. Now let's see if we have 5 wood on that line. If we have 5 wood on that line, it means we have a working machine, and we do not have 5 wood on that line. So wait for me. I don't know. Okay, we don't have, and actually now we don't even have nothing. Before we had something on that line, now we have nothing. So two things is either the U7501 that we replace is not good, or it is that it was not properly replaced. So let's see if we have 5 wood here on the output. 1.3. Nah, that's not okay. So let's try to resolder it, and then if it doesn't work, then we replace it. Okay. Make sure there is no bridge. We forgot to call back in a bit when we finish. Forgot to call back in a bit when we finish.
Oh,
Yeah, we'll call them.
yeah. It's already tried it before.
Say again?
Tried it twice.
Yeah, I'm gonna call them. Okay. So we had to resolder A7501. Let's remove that solder blob that is sticking out. Make sure there is no bridge. Okay. Just give it a bit of a cool. That's not actually giving you a cool, it's just a ceremonial type of cooling. Okay, now let's see what we have on our output. So we'll just see if we have 5 volts there. If we don't, then we just have to we check to see if we have an enable signal to it, and then if we do, then we just replace it. Okay, let's see what do we have 5 volt here. 1.3. So that's not okay. Now let's see. Do we have enable signal for E7501? Enable signal is going to be at pin 12. SMC BC SMC underscore PM underscore G2 underscore EN. So that is the enable signal for E7501. So two things we want to check. Remember we were having issue at was it pin 23? Yeah. Was it pin 23 and
No,
50
that's
watts?
23.
Okay. Let's see. The in let's say okay. Let's see if we have let's see what we have here. We should have 50 watts voltage at that. Let's see if it's there. Uh-huh. Okay. Wait. Do we have 50 watts? Yes, we have 50 watts. Let's see what do we have here. 0. 0.1 volt. And then this 0. 0.0 volt. Okay. Uh, okay, let's see the enable signal in 12. Enable signal. Enable signal we can get from here. R8140. Let's see if we have it. We should be get 3.3 volts there. Yes, we have the enable signal. Okay. Now let's see if we have let's actually open up let's open up the schematic of E7501. Okay. 165, 165, 820, 00165. And then U7501, U7501. Okay, so this is our E7501. We checked that we have our enable signal. Enable signal is present. Now, what we want to see, let's see our VN, pin 23. Let's see our VN. Let's see if we have voltage in on pin 23. Pin 23 is going to be this. Now, let's see what we have on pin 23. Because without that, E751 is not going to function. What do we have? We have 1.2. 1.2 is not going to give us what we need. Let's see if we have a breaking line. Okay, let's see here. Let's come to the other side. We're supposed to have, okay, let's measure, see what we have there. 8.5. Okay, it appears we have a breaking line. So you seem to be far away. Are you sure you've seen this? So 8.5. So on this side of the board, we're supposed to have 8.5. Yeah, on this side of the board, we do have 8.5, but on the other side of the board, we are getting 1 point something volts. So which tells us we have a break in communication. So if we check the other side of the board, uh, we have we have 1.2. So we have a break in communication. So what we need to do is we need to um, we can just run a wire. Yeah, let's just let's see. Okay, so we have a break. So we will run a wire from this point to this point here. So let's just do that because we have a break on our voltage in. Hmm. And also there's something here. You guys can see this. See that? Yeah. Let's do let's clean that out. Hmm. Okay. So what you want to do is you want to sew the wire here and then bring it to this side or all the way. Okay. Grab a wire. Let's see the length that we need. It's from here. Uh, uh, okay, that's about enough. Because this wire is coated, I need to remove the coating of the wire. I need to remove the coating at the tip. That's where I want to use my solder on. Okay. Now let's remove that. Okay. So take the wire and the chain, and this, and side. Mm, this. Well, it's too long, but it's fine. We'll kind of find a way to play around it. Okay. So what we now want to confirm, we want to be sure that pin 1 of and pin 23 are actually communicating, because otherwise, even though we have a wire there, we may not have. Okay, one way to confirm that is, let's just see what we have on our 509 now. Let's see what we have now.
What is second com?
What is it?
Group three.
I'll call it. We should be done with this moment from now, and then we can call all of those people back. Okay, let's see what do we have now. Let's see what we have here. We should have 8.5 here. Let's see, obviously, because the wire is bringing that voltage down there. That's 8.5. Now let's see what we have here on our 5-volt outputs. Let's see what we have. Okay, yes, that is exactly what we need to have. That's a 5-volt. Now let's check our SO rail, see what we have on our SO rail. 5-volt. That's exactly what we needed to have. Initially, we were having 1 point something volts there. So right now, I can now put my fan. Yeah, because now I know I'm gonna have a fan spin. So now my fan can be connected. Okay, we're expecting to have a fan spin. That is our fan spin. Okay, so the next quickly we want to do is, let's see if we have an Apple logo. Then we can address the wire, clean up the section where we were, and yeah, good to go. Let's see if we have Apple logo. We just need to have the screen connected, and then the DC jack, and that's it. So if we have Apple logo, fan spin, let's wait for an Apple. Waiting. Hmm, okay, yeah, that's a beautiful Apple logo. Yes, that is it. Okay, so guys, the next thing we want to do is we want to clean up that section, walk around our wire, and this will be a complete repair, and then we can move on to the next repair. So what you want to do is you want to clean up this section first. We will route the wire like this. Let's see. Can route it like this. Yeah. Route it like this. Hmm. Okay. So let's now clean out that section. Okay. we can move the wire aside, clean that section, and then put the wire back. Okay. You want to make sure the area you work is clean. It's important. Okay.
So if you want to change the wire, what is the other solution to do?
So again,
If you don't want to use the wire,
you need to create a communication. The wire is just to give you a communication from one point to the other.
that's why we're getting 8.5.
So again,
That's why we're getting 8.5 from the other side.
yeah, and the other side will get 1%. Okay, that's yeah, it's a clean board. That's it. Guys, that it's the end of the repair. This is going to go through testing and the device can be finalized. Thank you guys in the next repair.